Hi everyone. I wanted to quickly go over how to solve homework problem number 4 in assignment 8. So homework assignment 8 is looking at how firms behave in a monopoly. And this assignment is designed to kind of get at the heart of the differences between monopolies and perfectly competitive markets. But, it's a little bit complicated and the numbers are a little bit rough. And so I wanted to go over how to solve this problem really quickly. It's going to be a little bit of a fast and furious video. I'll try to do a little bit better job in the answer key. But I wanted to give everybody a sense of how to solve it for the homework before it's due tonight. So we talked about it a little bit in class and what the basic gist of what it should be, right? We're taking a market. The premise is that there's a small community served by 5 independent gas stations. And so each of the 5 firms produces 1/5 of the market quantity demanded or supplied at any given price level. And it's very competitive. And we have a table with cost curves and a demand curve and a supply curve. And so I ask you to graph demand and supply and the firm's cost curve, or a example representative firm's cost curves in a perfectly competitive market. And then after we do that and determine the profit maximizing quantity and price, we want to go back and assume now that the firm is going to there's going to be some consolidation. All the firms are going to be under the same ownership, and the market's basically going to turn into a monopoly. We want to look at how that's going to alter the outcome. So we start out with graphing the market demand and market supply together. And we can do that here with this information. So this is the table, information on the table from the assignment. So we've got prices here. We've got market quantity demanded going from 30 to 0. Market quantity supplied going from 0 to 30. And then each individual firm is going to be supplying 1/5. So at a quantity, if the market supplies 5 units of gasoline, each firm is supplying 1 at a price of $1, and it's going to go up like that. And so that's how we'll graph these marginal cost, average total cost, and average variable cost curves, is using this 1/5 principle. So I'm going to go ahead and graph those for y'all. And we want to do it like we would have in a perfectly competitive market situation. So I'm going to have my quantities down here, and I'm just going to go ahead and count these off in 5s. 5, 10, 15, 20, 25, and 30. And then in the price, since we're only going up to $6 in this example, I'll go ahead and make space for all those. I wish I had shifted that a little bit. I am going to shift it a little bit. I didn't give myself enough space. But that is the beauty of dry erase, is that we can go all the way up. So that'll be 6. That'll be 3, so that's 4 and 5, and that's 2 and 1. And then I can graph market demand and market supply. Market demand is going to be 0 gallons at $6, 5 gallons at $5, 10 gallons at $4, 15 gallons at $3, 20 gallons at $2, 25 gallons at $1, and if it was free, the market would demand 0, or demand 30. So that's our demand curve. And our supply curve is going to be the inverse of that, starting here with 0 at $0, and then $1, 5 gallons, $2, 10. Our equilibrium is going to be 3 and 15. Then we go to 4 and 20, 5 and 25, and finally 6 and 30. Giving us an upward sloping supply curve. And so that's going to be the market for gas in this community. And then we want to go ahead and graph our cost curves. And our cost curves are going to be on the same numeric scale in terms of price and cost. So I'm going to pull these prices over for $6, $3, and then the 5, 4, 2, and 1. And then down here, it's just going to be 1/5 of what it was in the market because these are just the little firm costs. And I'm going to go ahead and graph my marginal cost curve, starting with $4 for the first gallon, $2 for the second, $3 for the third. The fourth is going to go up to $5. And then we're going to fall off the chart here with, 4 is going to be $5, 5 is going to be all the way up at 8, and then 6 is going to be all the way up here at 10. So it's going to kind of just go off the graph, but that's okay. Then we want to go ahead and graph our average total cost curve, which is also going to be way off up here at 14 and out of scale. And then at 2, it'll be up to 8. At 3, it will come down to 6. At 4, it'll still be at 6, which will be right about here. And then at 5, it'll be 640. And then at 6, it'll be 7. So that's going to be like that. And then if we want to graph that average variable cost curve too, we do that too. We're going to use the average variable cost curve less and less when we're not worrying about the perfectly competitive markets as much. But it's still a nice practice because that is something you should expect to see on the midterm. And then 553, so it's going to be like right about there. That's our average variable cost curve. And then we want to graph marginal revenue. And marginal revenue is pretty straightforward. It's going to be that equilibrium price in this market, which is, oops, come on friend, $3, quantity of 15, which is going to come over here and translate into a marginal revenue curve of $3 and a quantity of 3. So in perfectly competitive markets, each firm produces 3 gallons of gas. The price is $3. Firms earn 0 economic profit. And that answers your first 2 questions, right? We've now graphed our curves and we found the market price, marginal revenue, and indicated the profit maximizing price and quantity. That's going to be this quantity of 3 and this price of $3. Now we get into the weird part. Now we're going to say what happens if there is a merger and all 5 independent gas stations are now owned by the same firm. This means that now one firm supplies the total market quantity. So instead of 5 firms each supplying 1/5, it's one organization supplying it. So now we have monopoly power. The firm's a price maker, not a price taker, one of 5 price takers. So now we want to calculate the total revenue and marginal revenue, which we'll do with this beautiful creature first. So we want to go through and find, okay, how much does this new firm earn in total revenue? And that's just going to be the quantity demanded times the price. So if they sell 25 gallons, they'll make $25. If they sell 20 gallons, they'll make 20 gallons times $2. That's 40. 15 times 3 is going to give us 45. 10 times 4 is going to give us 40. And then 5 times 5 is going to give us 25. And 0 times 6, if they raise the price to $6, they're not going to make any total revenue. Right? So total revenue is just price times quantity. But now, because they're a price taker, because it's a monopoly, what we're going to see is that downward relationship where as they raise the price, the quantity demanded decreases. And so they see the output and price effect mean that total revenue changes. Marginal revenue is going to change too. So this first, we want to calculate marginal revenue by looking at the change in total revenue divided by the change in quantity demanded. This is where it gets a little bit tricky. We haven't calculated this before, so this is one of those things that I apologize for not kind of being more transparent about, but change in total revenue divided by change in quantity is going to give us our marginal revenue. If you didn't calculate it this way, you'll still get the same general effect. Your numbers are just going to be shifted up a little bit. But we see total revenue here go from 0 to 25. So the change in total revenue is $25. And the change in quantity demanded is 5. So 25 divided by 5 is going to give us marginal revenue of $5. When we go from a revenue of 25 to 40, the change in total revenue now is going from 25 to 40. So that's going to be a change of $15. $15 divided by 5 units is going to give us a marginal revenue of $3. Then we go from 40 to 5, and we're going to divide that by the 5 units. So $5 in revenue change divided by $5 in quantity demanded is going to give us $1. And then we go from 45 to 40, so that's a total revenue change of negative $5. Negative 5 divided by another 5 units is going to give us negative $1. And then we go down by $15 here from 40 to 25 divided by 5 is going to give us negative 3. And then negative 25 divided by 5 is going to give us negative 5. So that's going to be our marginal revenue curve. And I'm sure this tripped some people up because usually on the exams, I'll always give you a change in quantity that's 1 to 1 to 1 to 1. But in this case, it's 5, 5, 5, 5, 5. So you have to divide that change in total revenue by the change in quantity. So our marginal revenue curve is going to be $5, $3, $1, negative $1, negative $3, negative $5. So now we have this information, and I'm going to stick this over here so I can see it just off screen. And I want to regraph this problem in a way that will allow me to change it from a perfectly competitive market to a monopolistic market. So I'm going to have that same market structure. And now the firms are going to be producing those because they're combined. We're not going to have the individual one company production. We're going to have the total market production be equal to what the company produces because all 5 firms work for the same company. And then our marginal revenue and marginal cost curve are still going to be about between 15 and 1. But we're going to also need that market demand. So let's do this. Let's do $2 here, $4 here, 6, 8. We're still going to go off the chart a little bit, but this will give us a little bit more of what we were looking for. So now I want to go ahead and do exactly what I did last time. I'm going to graph the exact same marginal cost curve, the marginal cost curve that starts with at a quantity of, now it's going to be the market supply quantities, right? The total market supply for those, for that market is going to be at 5 units. The firm is going to face marginal cost of 4. At 10 units, marginal cost of 2. At 15, marginal cost of 3. At 20, marginal cost of 5. And at 25, marginal cost is 8. And at 30, marginal cost is up to 10. And at least that curve now fits. I want to now graph average total cost. Average total cost is going to start at 14, which is still going to be off scale. And then it's going to drop immediately to 8 at a quantity of 10. And then 6 at a quantity of 15. 6 at a quantity of 20. 6.4 at a quantity of 25. And then 7 at a quantity of 30. That's going to be our average total cost. Average variable cost will be beneath that with 4, 3, 3, 350, 440, and 533. Then we get to graph our demand curve and our marginal revenue curve. So I'm going to graph the demand curve in this maroon color, And that's just going to be that market demand that was on a separate graph before when each firm was a price taker. But now that they're a price maker, there's no supply. They are the supply. Their marginal cost curve is the supply. So we're going to see that at a price of $0, the market is going to demand 30. And at a price of $6, the market's going to demand 0. At a price of $5, the market will demand 5, 4, 10, 3, 15, 2, 20, 1, 25, and that'll give us our demand curve. And now we want to graph that marginal revenue curve. Marginal revenue curve is going to start at a quantity of 5. Marginal revenue is going to be right here beneath the demand curve at $5. And then at a quantity of 10, marginal revenue is going to be down here at $3. At a quantity of 15, marginal revenue is going to be down here at $1. And then at a quantity of 20, marginal revenue is already going to be negative. So it's going to just come down here like that. That'll be our marginal revenue curve. And then what we want to do is try to figure out where the profit maximizing monopolist is going to produce. And they're going to produce, we know, where marginal revenue is equal to marginal cost. And this is where I really messed up. Marginal revenue and marginal cost aren't really equal. So if we look at this, I kind of skewed the numbers a little bit. I meant to have the 3 and 3 be equal at a quantity supplied of 10 units, but I didn't quite get there. So it's really going to happen somewhere in between 10 and 15. So you can kind of say, okay, well, maybe it's right here at 12 or 14 or some 13, something reasonable. I'm going to kind of just graph it and say, oh, well, on my graph, it looks like I'm going to say about 12. The point is that quantity is less than the quantity we saw in the perfectly competitive market. In the perfectly competitive market, quantity supplied equaled quantity demanded at a price of $3 and a quantity of 15. Now we're at fewer units of gasoline, and we're going to see the price be higher. It's going to be up here at maybe not quite, but almost $4, right? And so we're going to see a markup compared to where we were in the perfectly competitive market, and we're going to see a lower quantity. So that was the big idea, and that's sort of the big takeaway. The aha moment you're supposed to get is, wow, all we did was go from a flat marginal revenue given by the demand in the market and the supply in the market to a downward sloping demand curve in a monopoly. Cost curve stayed exactly the same, but now instead of being in equilibrium, $3 and 15 units right here where demand hits marginal cost, we're down here at a lower quantity than we would have been, right? If this would have been the perfect competition outcome. This is the monopoly outcome here. So this is where our monopolist is going to be producing below 15 units and charging a price above $3. That's the big takeaway. So when we graph that, we determine the new profit maximizing quantity and price. The quantity is lower, the price is higher. That's the big difference. That's the intuition that you're supposed to gain from this. So it's a little bit of a journey to get there, but hopefully that makes sense. I'll go over it again in the answer key for the homework. Let me know what you think, and I'll see you next time.